In this video, we'll be talking about systems engineering and scalability. So does one size really fit all, or do we need to scale these things to our particular environment? Well, keeping in mind first off what systems engineering actually is. Remember, we're trying to develop the right system, test it to the correct standards to satisfy some sort of business need throughout the life of the system, through some sort of a repeatable process. Now, we could do everything the same way, and we could do a full-blown systems engineering for everything that we're doing. But think about it this way. Systems engineering, we're addressing more how we actually go about the systems engineering process and the design process, not specifically and prescriptively what we do. And so what we're suggesting is we take a tailored design approach for each project. Now, what we're talking about is a general approach, and we'll talk about these general steps that will fit for all projects, but then we tailor it towards the actual size and scope and specific needs of the project. And this is something that we want to determine at the start of the project. As part of our contract, we'll say these are the things that we're going to deliver along the way, depending on how many baselines and documentation and things are required. So what we're essentially saying is systems engineering will be used most where it generates the most value and provides the most value to our design process. For small projects, we should be doing systems engineering. We should be coming up with good and thorough lists of requirements that will mean we actually build the right system the right way and test it to the right standard. But it won't be nearly as exhaustive as what we'd have for a larger system. And there's sayings in the aviation business that the systems engineering for a plane isn't done until the paperwork weighs as much as the plane. If you think about how many tons many of these planes weigh, we're talking about huge amounts of paperwork and huge amounts of documentation. And so that's the sort of systems engineering that we have at that scale. We've got dozens and dozens of subsystems and assemblies and thousands of parts that actually make these things up. For a small project, well, obviously we won't be doing that because we'll spend all our time doing the systems engineering and not actually doing the project. And so we'll use a very much abridged systems engineering process. Systems engineering could be applied from everything to the purchase of a mobile phone, where a user will say, oh, what are my requirements? What am I actually going to use this for? How long do I want it to work? What are my requirements related to serviceability and functionality? All those things are systems engineering questions, aren't they? To the design of something as huge as an aircraft carrier, which will have many different requirements and will cost billions of dollars and have a service life of 30, 40 years, something in that sort of order. Now, we've got numerous approaches to systems engineering, and there's approaches like the waterfall approach, incremental approach, evolutionary approach, spiral approach. These are all different approaches and use the same sort of systems engineering techniques. Primarily in this subject we'll be looking at the waterfall approach, but towards the end of the course we'll be looking at the other approaches and see how they fit together. And one important thing to note is the fundamental skills that we're learning in requirements analysis and validation, verification, all these sort of things apply and are used in all the different approaches, and so they make learning a different approach very, very simple and straightforward. They use these same sort of building blocks throughout all the different approaches.